Hi, this is Larry Feldman with a video on geometric series. If you haven't watched my video on geometric sequences, I would encourage you to watch that one first. In this one, we're going to talk about what happens when you add the terms in a geometric sequence, like I show on the screen there. We use this letter S to indicate the sum, and this subscript here of 4 means the sum of the first 4 terms. And here we have the first 4 terms listed: 16, 4, 1, and 1/4. And the common ratio is 1/4. That's found by taking any term and dividing it by the previous term. And we can come up with an explicit formula to represent each term in the sequence. It starts like this: a sub n equals a sub m times r to the n minus m. So what we can do is substitute some values in here. Let's use a sub 1 here. We'll sub in the 1/4 for r, and the exponent is n minus m. So it's n minus, here's m, so that's 1. Let's keep going. A sub n equals, a sub 1 is right here, so that becomes 16 times 1/4 to the n minus 1. And we can manipulate this a little bit more, but this is fine for now. Okay, now I'm going to introduce sigma notation. So that looks like this: s sub 4 equals summation. This is the Greek letter sigma. We can say n equals 1 to 4. This number is the same as this subscript, and it just means the number of terms that we're adding. This becomes a sub n. And this is equivalent to a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. And I did discuss this in my video on arithmetic series, but just to reiterate, you start with this n value of 1, sub it in for n, and write the term, a sub 1. Then you add, you just put the plus sign, increment this number by 1, so it becomes 2. Sub that in. Now we have a sub 2. You keep going until you reach this number that's at the top of the sigma, the 4. So s sub 4 can be represented by this, or represented in this sigma notation. Okay, let's clear the screen and keep going. Turns out that there's a really convenient formula used to find the sum of the first n terms. It looks like this: s sub n equals a sub 1 times 1 minus r to the n over 1, let me do that again, over 1 minus r. So let's do an example. We have s sub 3 equals a sub 1 times 1 minus r to the n, so this becomes r cubed. Since n is 3, we have to place the 3 here as the subscript and here as the exponent. That's over 1 minus r. And as a reminder, we have s sub 3 equals 16 plus 4 plus 1. So we're using the formula to evaluate this. Now obviously, doing it manually for 3 terms is much faster than using the formula. Here we get 16 plus 4 is 20, plus 1 is 21. But if you were asked to find, for example, the sum of the first 20, 30, 50, 100 terms, the formula would be faster. So let's keep going just to make sure that the formula works. S sub 3 equals a sub 1. This is a sub 1. So we sub that in. We have 1 minus 1/4 to the third. That's the value of r subbed in here. R was 1/4. Minus, over 1 minus 1/4. Let's keep going. S sub 3 equals 16 times 1 minus 1 over 64, since 1/4 cubed is 1/4 times 1/4 times 1/4. That's 1 over 64. This is all over 1 minus 1/4, which is 3/4. And we're in the home stretch now. We have 16 times, this is 63 over 64, which we can find by getting a common denominator. This is over 3/4. And jumping ahead and using a calculator, you will see, you can check me on this, that you get 21. Same answer here and here. Okay, so what would happen if we kept adding the terms in that series as n approached infinity? Here's the equation that we have for the sum of the first n terms, but what happens as n approaches infinity, meaning 16 plus 4 plus 1 plus 1/4, etc., and we never stopped? Believe it or not, if the absolute value of r is less than 1, your answer will converge to a finite number. In other words, s sub infinity, and this notation is not widely used, but I think it conveys the point. S sub infinity is the sum of an infinite number of terms in a geometric series as long as the absolute value of r is less than 1. This formula up here simplifies a great deal. In fact, it becomes a sub 1 over 1 minus r. And the reason why this happens is because of this term right here. If the absolute value of r is less than 1 and you raise that number to a really high power, this term vanishes. It approaches 0. So let's think about that. Let's say it was 1/4, which we've been working with for a long time now. What's 1/4 to the 10th or 20th? You have 1/4 times 1/4 times 1/4, and on and on and on. Well, that number keeps getting smaller and smaller. So certainly as n approaches infinity, 1/4 to an exponent that is approaching infinity is going to approach 0. So we get rid of this r to the n term, and we are left with this equation right here. So using our example that we've been sticking with for consistency, 16 plus 4 plus 1 plus 1/4, and on, what happens if we kept adding these numbers and we never stopped? Well, s sub infinity would equal a sub 1, which is 16, over 1 minus r, so that's 1 minus 1/4. This is 16 over 3/4, which is multiplying by the reciprocal of the denominator. That's 16 times 4 over 3, which is 64/3. And this is actually the same as 21 and 1/3. So let's think about that. We have 16 plus 4 is 20, plus 1 is 21. Everything after that only contributes an additional 1/3. Believe it or not. It does seem a little surprising, but the numbers get smaller so quickly that they don't contribute much to the sum. Okay, we're going to spend the next 5 minutes or so doing another example, and it's an important one. If you're studying this in school, you will most likely see problems of this type, and you'll thank me for covering this, because there's a hard way and an easy way to solve problems of this type. let's say you drop a ball from a height of h. Now in this case, let's say the initial height is 16 because I want to keep using the numbers that we've been using all along. Now the ball is going to bounce, but it's not going to bounce as high as the previous bounce. It's going to eventually, or it's going to gradually drop down, and it's going to stop bouncing at some point, and it's going to come to rest. Now, this is, as I said, this is a common problem in school. You will most likely be asked, what is the total vertical distance covered by this ball? Not horizontal distance, vertical distance. So in other words, the ball fell 16 feet and then it bounced up, and let's assume that it bounces up only 1/4 of the distance or height of the previous bounce. So this height, although this is not to scale obviously, this could be a height of 4, this could be a height of 1, 1/4, etc. We're working with the sequence like this: 16, 4, 1, 1/4, etc. So the hard way, but the way that actually serves to explain the problem more thoroughly, is to add up the down distances and the up distances separately, and then add those two answers together to get the final result. So how far does this ball travel in the down direction? Well, first it travels down 16. Okay, then it goes up, but we're not going to cover that yet. Then it travels down 4. Then it travels up, and then it travels down 1, and so forth. Okay, let's cover the up condition. Ball falls 16 feet. We already covered that. This is a down motion, which we covered here. Then it travels up 4, then down 4, then up 1, and so forth. So we have two infinite geometric series here. This one we can call SD infinity. This is sum of the down distances. And this equals, well, let's come back up here. S sub infinity was a sub 1 over 1 minus r. So the sum of the down distances is found by using this a sub 1, which is 16, over 1 minus 1/4, which is 16 over 3/4, which is 21 and 1/3. Now when we look at the up distances, we have the sum of the up distances as they go to infinity. We use the same formula, but a sub 1 is different. It's no longer 16, it's 4. So we have 4 over 1/4, 4 over 1 minus 1/4, which is 4 over 3/4, which is, multiplying by the reciprocal, 16/3, which is 5 and 1/3. So when we add the total distances up and down, we get the answer, which is 21 and 1/3 plus 5 and 1/3, which is 26 and 2/3. And now for the shortcut, and I'm usually not a fan of shortcuts, but this can come in handy to check your answer, as long as you promise me that you are going to make an attempt to understand this problem the long way. The shortcut says that the total vertical distance is the initial height times 1 plus r over 1 minus r. That's it. That adds the up and down distances. So assuming an initial height of h, here we have 16 times 1 plus r, so that's 1.25, over 1 minus r, that's 0.75, and you can check me with your calculators. This is also 26 and 2/3.